Hello there, let's continue with Chapter 4. This is Chapter 4, Part 2. What is the probability that a couple has 4 children and that all 4 of them are girls? Well, there is a way to make this in a giant table, but let me explain what's happening here. First of all, we'll assume that the probability of a boy or a girl is 50-50. And second, what you need to notice here is that they have 4 children. So this is called a compound event. Compound, C-O-M-P-O-U-N-D. And that's where we have one event, and then another event, and then another event, and then another event. And we need all of them to be true. And so it's 4 children, and we need all of them to be girls in this example. And when you have multiple events, the way you calculate their probabilities is by multiplying. Here's how you do it. Because the probability of a girl is 0.5, the probability of 4 girls in a row would be 0.5 times 0.5 times 0.5 times 0.5. And that gets small pretty quickly. Whenever you have compound events, the probabilities get small real fast. You'll notice that there's only a 6.25% chance of that happening, which is about 1 in 16. So we're going to look more at compound events later. By the way, these are called independent events because one does not have an influence on the one before it or the one after it. It's just half times a half times a half times a half. And we'll talk more about this idea of compound events a little later. The next example. In a genetics experiment on peas, one sample of offspring contained 419 green and 306 yellow. Based on those results, estimate the probability of getting a pea that is green. Is this close to the value of 3/4 that was expected? What am I going to say? Can you predict? Can you predict what I'm going to say? We need to find the... This feels like Blue's Clues, where I say the word, it's like, what do you say? We need to find the total. We need to find the total. If you're stuck on a probability question, it's always a good idea to find the total. So we do that. 419 plus 306 gives us 725. And the problem won't tell you to do that. You need to know to do that. We want the probability of getting a green pea. So that's going to be 419 divided by the total. And so you get a result of 57.79%. Now they were saying, is that close to 3 out of 4 that was expected? So this is a little subjective. What I recommend you do is convert 3 out of 4 into a decimal. And 3 out of 4 is 0.75 because it's 3/4. And I would say that that's not very close to 57.79. Just that's 75% versus 58-ish%. That's a pretty big gap. I don't know how big of a gap they consider to be close or not. If it was within a couple percentages of 75, I would say that's close. 57 is quite far away from 75, so I would say that that's not close. 10 of 100 digital video recorders in an inventory are known to be defective. What's the probability of randomly selecting a recorder that is defective? This one's not too hard. Once again, it's just the number of successes divided by the total. In this case, a success is getting one that is defective, and so that would be 10 out of 100, which is just 10%. Notice that the complement of that would be 90 out of 100 because 90 of them work. And so the probability of picking one that's working is 90%, which is the complement. Notice that would add up to 100% if we added it to the 10%. What is the probability of exactly 3 boys being born in 3 children? This problem is very similar to the 4 girls one. Again, we'll assume that it's 50-50 for the probability of a boy. And so the probability of 3 in a row, because these are independent events and there's one after the other, we need to multiply them together. So it's a half times a half times a half, which is 1/8 or 0.125. So the probability of 3 boys is 12.5%. And as I mentioned, we'll talk more about compound events in a minute. Okay, everything we just did is probability. So everything we just did, all of those examples, every single question we just did is probability. And when I say probability, what am I talking about? I'm talking about the number of successes divided by the total. Okay, that's what we do most of the time. That's probability, the number of successes divided by the total. Another thing we can calculate is the odds of an event, and that's calculated slightly differently. The odds of an event are the number of successes divided by the number of failures. Okay? So it's a slightly different calculation. Most of the time we'll do probability, but it is also important to know how to do odds. So it's the number of successes divided by the number of failures. So here's an example. What is the probability of rolling a die and landing on a 6? Well, the probability of that is 1 out of 6 because there's 1 6 and there's 6 total outcomes. So the probability of that is 1 out of 6. But what are the odds of rolling a 6? Well, the odds of rolling a 6 is there's 1 6 on the die and there's 5 numbers that are not a 6. So there's 1 success and 5 failures. All of these mean the same thing. So the odds would be of rolling a 6 are 1 to 5. With a colon, this also means 1 to 5. Or you can write it 1 over 5. Now, I don't like using this one because it gets confusing. The one I prefer is the colon, because when you see a colon, usually you're talking about odds. So I recommend you use the colon of 1 to 5. Now, there is a connection between the odds and the probability, and maybe you can already see what it is. Notice that because the odds of an event are the number of successes over the number of failures, if you add the two numbers together, you get the total, because it's the failures plus the successes. So notice that if we add 1 plus 5 together, we get the total of 6 that we see in the probability. So that's a way to test your answer to make sure you did it correctly. So 1 to 5, 1 success to 5 failures. Let's look at some examples. Okay, so here are some examples of odds. Let's imagine that there are 12 trains and 3 of them will be late. So we have 12 trains and 3 of them will be late. What's the probability of being on a late train? Well, the probability of being on a late train, remember, is the number of successes, in this case being late, divided by the total. So the probability of being on a late train is going to be 3 out of 12, which is 1/4, which is 25%. Because there's 3 late trains out of 12 total. What are the odds of being on a late train? Well, the odds are slightly different. For the odds, it's the number of late trains, and then the colon, and then the number of trains that are on time. And so you can see that you just subtract the total minus the number of late trains. And so if there's 3 trains that are late, there will be 9 that are on time. And so the odds of being on a late train are 3 to 9. Okay, because the late train number, the number in here comes first. So 3 late trains, 9 on-time trains. So it's 3 to 9, and you should reduce that if you can. So that reduces to 1 to 3. So just like a regular fraction, you'll want to reduce it. And so the odds of being on a late train are 1 to 3, and that's because there's 1 late train for every 3 on-time trains. You see this odds a lot when you look at like sports betting and gambling and things like that. And we'll talk about that a little bit later too. Here's an interesting question. What are the odds against being on a late train? So do you see how this one has the word against? The odds against being on a late train is you just flip it. So you just flip whatever it is that you're finding. And so you can see that that's what I've done here. Let me hide myself for a second. And so the odds against being on a late train is the early trains divided by the late trains. And so you just flip it 9 to 3 or 3 to 1. So you see how that's just the flip of the odds of being on a late train. Late train is 1 to 3. Against late train is 3 to 1. Now, if you have the fraction 3 to 1, it's important that you don't write 3, because then you lose some meaning. So it's 3 to 1. And we should keep the 3 and keep the 1. But otherwise, you should reduce the fraction. Just don't convert it into a number. Make sure you keep it 3 over 1. So hopefully odds make sense. We're not going to do too much with odds. We're mostly going to work with probability. Here's an example that's similar to what's on your homework. Roulette is the worst game in the casino, pretty much, in terms of your odds. Like, slot machines are probably worse, actually. But roulette is pretty bad. A roulette wheel has 40 spaces. Those spaces are numbered 1 to 38. Then you also have the 0 and the double 0 on the roulette wheel. And so what we're going to do is walk through how this works. What's the probability of winning if you pick a number that is a multiple of 5? So you're going to put a bet on every single multiple of 5. By the way, 0 and double 0 do not count as multiples of 5, just so you're aware. I think we'll just go through this one piece at a time. So how many multiples of 5 are there? There's 5, 10, 15, 20, 25, 30, 35. So there's 7 numbers that are multiples of 5. And so the probability of betting on one of those numbers and winning is those 7 divided by the 40 spaces on the wheel. And once again, we do not count 0 and double 0. That's where the house wins, typically, is when it lands on one of those two. So you can see that probability of landing on a multiple of 5 is about 17.5%. Okay, so then what are the odds for winning? What are the odds for winning this bet? Well, we have 7 successes, and so that means we have 40 minus 7 failures. And so if we do 40 minus 7, we get 33 failures. So the odds for winning are 7 to 33. Because we win 7 times and we lose 33 times out of 40 games. So that's the odds of winning are 7 to 33. What are the odds against winning? Well, the odds against winning, you just flip it. So that would be 33 to 7 would be the odds against winning. So here's how you can calculate if you should make the bet or not, because it depends on how much they pay out. If they pay out a ton of money and you only have to bet a little bit, we should play. However, most of the time we should not play, as you'll see. So if you make a bet, the payment odds are 1 to 2. Okay? So the payment odds are 1 to 2 if you make a bet on a multiple of 5. So what does that mean? What that means is it tells you how much money you'll win if you win. And the way to calculate it is you just flip the payments. And so 1 to 2 means it's doubling your money. And so just flip this to 2 to 1 and then multiply, and that's how you can calculate your winnings. So if it was 1 to 3, that means it's tripling your money. So you just flip it, multiply by 3, and put the number there, depending on what it says in your homework. So if you win and bet $15, the payout is $30. So now the question says, how much profit should we earn if it was a totally fair bet? So if it was totally fair, then how much profit should we earn if it's a fair bet? The casino is giving us 1 to 2. So is that fair? Well, the way you calculate what a fair return would be, and this is important, the way you calculate how much you should win if it was fair is by multiplying your bet times the odds against winning. Okay? You multiply your bet times the odds against winning, and that's how much it should pay if it's a fair bet. And so we should win $70.71 if it was fair. And the reason we should be paid that much is because we're less than half likely to win. We only have a 7 out of 40 chance to win. And so we should be compensated by that because it's less likely to win. And so the fact that the casino is only paying us $30 when we win, when we should be being paid $70.71, we see that the casino is just laughing all the way to the bank. Like, this is terrible odds, and we should not be playing this game, because when you do win, it won't be enough to make up for all the times that you lost. And so we should not be playing this game. So hopefully you can see the start of how some of this probability is useful. Let's go ahead and dive into section 4.2. So that first section is just on the fundamentals of probability. In section 4.2, we are going to do some more examples. So to review, an event is any collection of results or outcomes of a procedure. In fact, I'm going to stop the video here and have 4.2 start on a new section. I'll see you in the next video.